Hello, my amazing students. We are starting with 1.5, which is the last section that is on your test. So I'm going to start doing about every 10th problem, but right at the beginning, I did a lot more than that just because of practice in solving equations. So the first one we're going to do here is this one right here. 3 minus 1/4 x is equal to 3/2. So remember, when we are solving, our goal is to get the x alone. Okay, and on the board, I had put some steps that we're going to go through when we are solving an equation. So some of the steps were back over here just in the simplify. We were going to sometimes multiply by an LCD or a power of 10. Because if we have fractions, we want to multiply by the LCD. And if we have decimals, we want to multiply by a power of 10 to clear that out. Now, usually before that, we distribute. But in this problem, we have no distribution to worry about. And then after that, we are going to gather like terms or add them together. And then we'll actually start into the solving part of the problem. But this is just kind of like a simplify here. We're going to simplify before we start working the problem to make it easier for us. So on this one, I notice that I have fraction, a 4 and a 2. And the least common denominator between a 4 and a 2 is a 4. So I'm going to multiply the whole thing by 4 on both sides, all the way across. So I'm going to get 4 times 3 is 12. Minus 4 times 1/4 is just 1, so that's going to leave the x, is equal to 4 times 3/2, which is going to be a 6. Okay, there's my equal sign. All right, so much friendlier to look at. And remember, when we're trying to solve, we're going to get our x alone. So we've basically done all the simplification that we can do, because on this one, when I say, we'll just say combine like terms is in that step, not gather. Combine like terms, okay? So now we're actually going into the solve of the problem. And when we're solving, we're trying to get x alone. All right, so if we're going to get x alone, we're going to subtract the 12 and subtract the 12 from both sides. So now we're going to have, this cancels, negative x is equal to a negative 6, but we don't want negative x, we want positive x. So we're going to multiply both sides by -1, and that's going to give me x equals 6. And then I should check, right? So I'm going to plug x is 6 back up in here. There's my 6 right there where my x is. And 3 minus 6/4 is the same thing as 3/2. And 3/2 is the same thing as 1/2. And 3 take away. Now we can get a common denominator if you want to go ahead and do that. Remember, 3 would be 12/4. Okay, so 12/4 take away 6/4 is 6/4, but 6/4 can be simplified to 3/2. And so this checks. We have the correct answer. And that is that problem number 9. Okay, so now I'm going to show you problem number 10 on 1.5. In problem number 10, notice right away we have something that kind of stares at us. And we have a 10x and a 10x. And those are the only x's that we have. And so if we try to get all of our x's on one side of the equation, guess what's going to happen? We're going to subtract the 10x from one side and the other side, and then all of a sudden, no more x's, they all disappear, and we get -3 equals 8. But -3 does not equal 8. Therefore, there is no solution. Okay, so when we're doing a problem like this, if our variables disappear, okay, if our variables just disappear and we are left with a false statement, then we have no solution. Okay, no solution. Now, if our variables disappear and we're left with a true statement, then we would have our solution be all real numbers. So those are our two special cases, and this is an example of a special case problem. We have no solution because we were left with a false statement. That is number 10. So now we're moving on to number 22, and we have nothing that we can do to simplify. We have to start right into the solving part of the problem, which I'm going to say number 1 of solving is gather your variable terms. Okay, if you have your variables everywhere, there's no way you can solve for your variable if you've got it in several different places. So we usually want our variable on the left, so I'm going to subtract 2x from both sides to get all my x's on one side. So this is going to give me a 2x plus a 3. This cancels, equals a -7. So now I'm going to step 2, get variable term alone. Okay, so I'm going to get the variable term alone. All right, in mine, I'm trying to get the 2x alone, so I'm going to take away the 3, take away the 3, and I wind up with 2x equals -10. So then lastly, I'm going to get the variable. Get variable itself alone, or isolate the variable. So divide by 2, divide by 2, x is -5, and that should be our solution. But again, we don't know if that's the solution unless we go back and check. So we're going to plug x is -5 back in here, -5, and go back to our original equation, and we're going to say -20 plus 3 on one side, okay, and then on this side I'd get -10 minus 7. -10 minus 7. Well, -20 plus 3 is -17, and -10 minus 7 is also -17. So there's the whole board there if you missed getting any of those notes. And that is the end of 22. So we're going to come over here to 27. And there's 27. So now on this one we have, so remember up in the little simplify, we had to distribute. So this is one where we're going to have to distribute, and we're going to take this and multiply it through. Now notice I have a parenthesis, and the only thing I have in front of it is a negative. We can think of that negative as a -1. Okay, we have to distribute that -1 to both parts before we can take that out of the parentheses. So now we've got 21x plus 42 equals 11. Take away x, take away 2. Yeah, that looks right. Okay, so now I'm going to I don't have any fractions or decimals, so I get to skip that second part, and then I'm going to combine like terms. Okay, so when I'm combining like terms, I am looking just at each side, and there's nothing I can really do there because those are not like terms. But over here I have an 11 and a -2. So when I simplify to get it as simple as I can get it before I start, I get -x plus 9. Okay, so now that's about as simple as I can get it. And now I have to start actually the solving process. Okay, so we just saw on the last board, the first of the solving process is get all your variables together. So gather your variables. Okay, and so I'm going to add an x, and I'm going to add an x over here. And then I'm going to get a 22x plus a 42 equals a 9. Okay, so now my second step is to isolate variable term, not the variable itself, but the term, and there's my variable term. So I'm going to subtract a 42 and subtract a 42, and that's going to give me a negative 33, okay, on the right side, and then on this side I got a 22x. So now, lastly, number 3 is I'm going to isolate the variable itself, okay, which means I'm going to get the x by itself by dividing by 22, okay. So now my x is negative 33 over 22, but notice that 33 and 22 will both divide by 11. So I'm going to end up with negative 3/2. Negative 3/2. Okay? So now, to find out if that works, I would have to go back up here and plug in a negative 3/2 here and a negative 3/2 here. Okay? So if I plugged in a negative 3/2 here, I'm going to get a negative 9/2 here. So I'm going to just erase this. First of all, get all that up. Make sure you have that, because I'm going to erase a little bit just so that I can show you the check and that it works. Okay, so I'm going to just erase these 2 lines right here so I have enough room to check, since we've already done that. Okay, so now we're going to have 7 times negative 9/2 when I plug in my negative 3/2 here. Plus, instead of 6, I'm going to call 6 12/2 and get that common denominator that I need. And then over here on the other side, I'm going to get 11 take away, and then I've got a negative 3/2, and then plus, I'm going to get rid of all this because we don't need it anymore. Okay, plus 4/2. Okay, so when I finish my problem, I'm going to be able to put these together and get a 3/2 times a 7, which is going to be 21/2 on the left. And on the right, I'm going to get, put these 2 together, and I'm going to get 1/2. So I end up with 11 minus 1/2, but 11 would be 22/2. So 22/2 minus 1/2 is 21/2, and it works. Check. Okay, so there's the check portion of the problem. And that is the end of 27. And moving on to 32. So 32, again, another distribution problem. Now I have to distribute on both sides. So I'm going to get a 6x minus a 15 plus a 4 equals an 8x plus a 6. Okay? So now that I've distributed, I'm looking, do I have some like terms that I can combine? I can combine some constants right there. So I get 6x minus 11 equals 8x plus a 6. Okay, so now I'm going to get all my x's together. So subtract 8x on both sides. Always gather your variables. So negative 2x minus 11 equals 6. So I'm trying to now isolate this term, get it by itself. So add 11. Okay, so we get negative 2x equals 17. Okay, so x divide by negative 2, divide by negative 2. And we're going to get x equals negative 17/2. Okay, well, now this one's not going to be very hard to check. I'm going to show you that so that you can take any notes that you want to take on this one. Okay, so now I'm going to get rid of that. So we have a little place to work for our check. Okay, so now when we go ahead and plug in our negative 17/2 here, we're going to get 3 times 2 times the negative 17 halves is just going to be a negative 17 minus a 5 plus a 4 equals 2 times, now 4 times a negative 17 halves is going to be a negative 34 plus a 3 because of the cancellation. So now I end up with 3 times a negative 22 plus a 4 is equal to a 2 times a negative, that becomes a negative 31, and 2 times a negative 31. Okay, so let's see how we're doing here. So then this one becomes a negative 66 plus 4 is a negative 62. And that looks good to me. All right, so that's another problem that checks out. And we have finished problem number 32. So I will be back with some more problems shortly after I clean all my boards off. All right, so now we are back with some more of 1.5. And we're going to start talking about some of the word problems that are in there. And you know how much I love word problems. I know y'all love word problems too. We're going to talk about one with borrowed money, and the money was borrowed at 5% simple interest, and at the end of 1 year, the student owed $1,365 in principal plus interest, and we're to find out how much did she borrow. Okay, so we know that we're going to be using interest is principal times rate times time, which is our simple interest formula. And right now we know that time is 1 because they said that she was going to only borrow this money for the first year, or this is at the end of the first year. So T in this equation is always in years, so T is just 1. We can pretty much cancel that one out. And so we have interest is principal times rate. Now we already are given the rate, and so we're going to say the rate, get rid of that T, the rate is 0.05 because that's how we write 5%, 0.05 is our interest rate. So now we know that this is our interest on the amount of money that she borrowed. And what is the principal? That is the amount of money that she borrowed. And so at the end of the 1 year, she owed $1,365, which included the principal that she borrowed plus the interest that she owed. I think it was her grandfather or something here. She owes 0.05p for interest, and altogether the two of them add to $1,365. Okay, so now we've got all of the parts of the problem written down in our equation here. So now, since this is just 1p, and then this is 0.05p, when I add them together, I get 1.05p equals 1,365. Okay, so now to find my principal, all I'm going to do is divide both sides by 1.05, and I'm going to get my calculator and put in 1,365, and I'm going to divide by 1.05. 1,365 divided by 1.05, and I got that she borrowed $1,300, $1,300. Okay, so to check it, we could take the 1,300 and we could take times 0.05. Okay, so times 0.05, and we're going to get $65 in interest. So she had borrowed this amount, 1,300, and she had $65 in interest. And when you add that all together, it does equal the amount that she owed, so that we knew that we had done that one correctly. Okay, so now we're going to do number 37. And number 37 is a triangle problem. Okay, so we've got Angle B is 5 times as large as angle A. So we're just going to call angle A X, okay? And then we're going to say this is 5 times X. And then angle C is 2 degrees less than the measure of angle A. So since this is angle A, then this one is angle C, this one was angle B, and C is 2 degrees less. So we just have X minus 2 down there in the corner. And then it says find all 3 degrees. Well, the hint to this one is given to you in the book, and the hint is that the sum of all of the angles is always 180 degrees in any triangle, no matter what its shape. So now I'm just going to add these 3 together, x plus 5x plus x minus 2 equals 180. Okay, so I have my little equation to solve down here. And I don't really need these parentheses. And the reason I don't need these parentheses is there's nothing in front to distribute, so I'm just going to get rid of that. Okay, so I've got x plus 5x plus x, so that's 7x. Take away 2 is 180. Okay, so I'm going to add a 2 to both sides to get my 7x by itself. And so then I would get 7x is 182. So if I go to my calculator and I say 182 divided by 7, then I find out that x is 26 degrees. Okay, so let's check it. 26 degrees is this one right here. So let's put in 26 degrees. All right, and then this one is 5 times 26, so let's take 26 and multiply by 5, and we get 130. So this one up here is 130 degrees. And then this one here, C, is x, take this A angle, take away 2, so it's going to be 24 degrees. Okay, so we're going to add all of those up and see if we do get 180. Well, I know that 24 and 26 equals 50, and 130 plus 50 is 180. So we have checked our work, and that is our triangle problem. And that is problem set number 37. That's the number 37. Okay, so now we're going to do a train problem. And this train on problem 41 is saying, okay, we have a slow train, which is a freight train, and it is leaving the station, and it is headed north at 60 miles an hour. So here's my little chart up there, my little graph. And then 1 hour later, dun, 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 passage of time, then we have this train is now an Amtrak, and it is leaving the station at 80 miles per hour. So we have to reflect this passage of time. And so the problem starts when the second train leaves the station, because you're trying to find out how long does it take the second train to overtake the first train that's on a parallel track. Okay, so what we're going to do is we're going to let the Amtrak, which is the second train, the faster train, we're going to call its time T. Okay, and since this train will have already been traveling for a whole hour before this one even starts, we're going to call this one T plus 1 because it gets to travel an additional hour. Okay, so the freight train was going at 60 miles per hour, and the Amtrak train was going at 80 miles per hour. And I don't know what their distance is, but I know their distance is the same. Okay, and remember that distance is rate times time. So I'm going to say this distance here is going to be 60 times T plus 1. Okay, so I'm going to erase this one so I have room to write that. So 60 times T plus 1. And then this distance here is going to be 80T. Distance is rate times time. So since I know the two distances are the same when the one train overtakes the other, then I'm going to set the two distances equal. So 60T plus 1 is the same as 80T. Okay, so now all I have to do is distribute the left-hand side and solve for t, because t is what I'm looking for. So 60t plus 60 is 80t. So when I subtract the 60t from both sides, then I wind up with 60 is 20t. So now I'm trying to solve for t, so I divide by 20, and I divide by 20, and it's going to be 3 hours before the Amtrak train takes over the other train. So let's check it. How do we check? If we plug in 3 hours right here, then this train traveled 4 hours, and 60 times 4 is 240 miles. Okay, and then when I plug in the 3 right here, this is also 240 miles, and that's when they're going to be neck to neck on those two parallel tracks, because they both are at the same spot in time. And that is the end of problem number 41. And I'm going to stop right there because I think I have enough to try to upload. It takes me a while to upload these, so I'm going to go ahead and get those uploaded before I do the rest of the problems. So we'll be back with another video, part 2. I hope you're liking the videos, and I hope that they're helping you. So that was the first part of 1.5, and we will come back with a second part of 1.5. Look for it to come up here in a couple of hours. This is Mrs. A, and may God bless your day.